Hi, today I am going to be presenting my project where I used envelope models to model ecosystem distribution and then climate change predictions to model how ecosystems will shift in the era of climate change. My work is just part of a larger project. I am only training my model on climate data, so field testing is essential, and hopefully at the end of this project we will have actionable management initiatives. So taking a look at my methods, like I said, I'm using envelope models. My target variable is going to be ecoregion, so it's going to be at the ecosystem level. And I'm going to use historic climate data to train the model to predict ecoregions. And then I'm going to use predicted future climate data, and I'm going to use that to predict how these ecosystems will shift across North America. So, looking at the ecoregion, the target variable in particular, I used this ecosystem data. This was the most granular data I could find. The figure on the right, that's the level 4 ecosystems, and that was the target variable that I chose. I ended up with 2,050 classes, and level 1 sort of just shows you a broader ecosystem view and distribution. Now, looking at the historic climate data that I decided to use, I got that off of the Climate NA option on Andreas Hammann's website. They took sort of weather station data and made a continuous climate model for historic climate data, and that is what I'm using to train the model. It has around 250 bioclimatic climate variables that are the input to the model. Now, getting into the modeling. I tried 3 different models, going from least complex to most complex. I tried an LDA, a random forest, and a neural network. At the moment, the random forest was outperforming all of the other models, so that is the model that you will be seeing the results of for the rest of the presentation. So, looking a little closer at the random forest, the 3 most important features were continentality, and then precipitation from May to September, and then summer precipitation. So I thought it was interesting that mean average temperature or summer temperature, stuff like that, wasn't the biggest importance. It was continentality followed by precipitation. So now looking at the predicted future climate data. I had to choose sort of scenarios. I chose 3 scenarios. They're called social shared pathways. The first one, 245, is very optimistic. 370 is sort of middle of the road, and 585 is sort of business as usual. And then I chose 2 different decades of climate data, the 2050s and the 2080s. And then I used a ensemble of 8 general circulation models to get sort of a very pretty conservative, averaged general predicted climate. Now, getting into the model output. This is sort of a psychedelic figure that is not too insightful because I do need to decrease the number of ecosystems on display here. But at the moment, you can see that the green ecosystem is sort of shifting northward, getting taken over by the pink one. And again, this will be more interpretable in the future. But as of right now, this is sort of the 3 shared pathways and how they are shifting. Now looking at some averages of the model's output. So as the emissions increased, fewer and fewer ecosystems were predicted to be in the new distribution across North America. And again, there were fewer ecosystems predicted to be in 2080 versus 2050. So this is an interesting trend, and further analysis on the ecosystems that are being lost, if they're being lost due to losing elevation or shifting too far north, etc. So more analysis on why there is this decrease in number of ecosystems is important. Also, on average, ecosystems did shift north. They actually shifted north further than I was expecting. And they shifted north in sort of an expected pattern. The more emissions, the further north they shifted, and the later time period, the 2080s, also shifted more than the 2050s. And again, we see this pattern, but with elevation. So this is sort of shifted in elevation northward, and it's that same pattern. Higher emissions has more of a shift, and 2080s also has more of a shift than the 2050s on average for all of the ecosystems in North America. Now, just looking at next steps really quickly, I would like to really intentionally look at the feature selection. First, looking at bioclimatic indicators that are really important for tree growth, and then also select the features that will be most affected by climate change. And then lastly, I would also like to add in some analysis on novel ecosystems. So right now, the model is having to give a prediction. I would like to give the model an option to, if it has a very low confidence, to say that there is no new predicted ecosystem in that area. And then lastly, I would like to analyze the model's impact on tree species distribution. So add in tree species distribution data. And lastly, here are my acknowledgements, and thank you for watching.